Good morning on and all present here. This is Dr.S.Sumathi, Professor heading Department of ECE. This semester I would like to take the subject of embedded system. The first unit is introduction of embedded system. So now let us see the content of the embedded system, first unit. So one of the topic of first unit is challenges in embedded computing system design. So in this, first of all, we would like to see how much hardware we need. Okay. So under this, apart from the type of microprocessor used and to be taken to select the amount of memory and peripheral devices, etc. So both performance deadlines, manufacturing cost constraints should be met. Okay. So in this, how much hardware we need, we should know about the hardware design of the system. So it's too little hardware system fails to meet its deadlines, and also too much hardware it becomes too expensive. So next one is how do we meet deadlines? First of all, the brute force way of meeting deadline is to speed up the hardware so that the program runs faster. It makes that the system more expensive also, and increasing the CPU clock rate may not make enough difference to execution time, since the program speed may be limited by the memory system. So these are the contents under, it comes under the how do we meet the deadlines. And the next one is how do we minimize the power consumptions. Of course, in battery powered application, power consumption is a very important point, and non-battery application, excessive power consumption can increase heat dissipation. So that one way to make a digital system consume less power is to make it run more slowly, but slowing down the system can obviously lead to. Okay. So this is the points comes under the minimize the power consumption. And next we do design for upgradability. So how to design for upgradability is also important point under this. And the hardware platform may be used over several product generation or for several different versions of a product in the same generation with few or no changes. So next one is, does it really work? Of course, reliability is always important when selling products. Customers rightly expect the products they buy will work. Okay. And also reliability is especially important in some applications such as safety critical systems. So the next topic is complex testing. So the embedded system generally more difficult than typing in some data, and also observability and controllability also it's a limited one. Embedded computing system usually don't come with keyboards and screens. This makes it more difficult to see what is going on and to affect the system's operations. And next one is restricted development environments. The development environments for embedded system are often much more limited than those available for PCs and workstations. So these all are coming under complex testing, and so these are the topics we are concentrate how we facing the challenges in embedded computing system design. So next one is the embedded system design process. Okay. So there are three reasons to design the embedded system. The first one is it allows to keep a scorecard on a design, for example optimizing performance. Second one, it allows us to develop computer aided design tools. Third one is a design methodology make it much easier for members to design team to communicate. So this is the three reason we are going for the considering the importance of the embedded system design process, and these are the steps of involved in embedded system. So there is a top down approach and also bottom up approach. We take it in the top down approach, we need requirements and specification, and we go for the architecture and components, and finally we'll go for the system integration. So bottom up approach will go in the reverse order. We'll start from the system integration, components, architecture, specification and requirements.